Students, here we are having a problem. These are the example problems. In this problem, you are having a cross section of this walls, internal inside the building and outside the building. This is outside the building and this is inside the building. So we are having 12 dense plaster. So plaster means covering of this wall with cement paste. This is 12 We are having block work, so it is called as block work of 90 and we are having brickwork of 100 So this is showing the air gap between the inside and outside walls, and this is external surface. So this is the diagram we are having. So what is asked is calculate the U value for a partially filled brick and block masonry cavity wall. So we have to calculate the U value. The structure of the wall along with the information and the thermal conductivities of the material and standard value for surface and air gap resistance are given below. As we have discussed, the surface and air gap resistance are the standard values. So from the problem they have given the thermal conductivities of these materials. So dense plaster is having 0.3 thermal conductivity. Block work 100 block work is having 0.10 thermal conductivity. Brickwork, so this is block work and this is brickwork is having 0.75 thermal conductivity. So we are having external surface gap resistance, surface and air gap resistance for the external surface is 0.04 and the air gap resistance is 0.13. So I'll explain you how to solve this problem. You may be asked to do some activities in the classroom regarding these problems. So the thermal resistance of the components of the wall are calculated and then added the resistance of the surface and air gap. So see here the thermal resistance of the components of the wall. So you have to calculate the thermal resistance for these three items and you directly add these thermal resistance to this values. So how to find this thermal resistance? So we are having formula for thermal resistance. Thermal resistance R is equal to D by lambda. So from the problem we are having D means this thickness in meters is D and thermal conductivity is given in the problem. So D by lambda, so D means it is 12 here, I converted into meters 0.012. so you know this D here, lambda you can take this 0.3 from the problem. The thermal conductivity of dense plaster is 0.3. so if you solve this, R is equal to D by lambda, it is 0.04. So like this, if you take the block work thickness as 0.09 as it is 90 here, it is 0.09 meters. Thermal conductivity of block work is 0.10 here. So like brickwork, so you calculate thermal D divided by lambda is giving this value. These are the three values calculated from this thickness and thermal conductivity, and these two values are directly given here, external surface and air gap. So add all these 5 and you will get sigma thermal resistance is as 1.24. You are having formula U value is equal to 1 by sigma R. U value is 1 by sigma R. You can check from it here. The value of U is 1 by sigma R. So if you solve this, you will get the answer like this. This is the U value. This is one type of problem. You can expect different. I will change the values and will give it to you in the classroom. So come prepared to the class to solve this problem, and this is very easy problem. As only thing is consider the thickness and convert into meters. Write down this lambda values, thermal conductivity values. Just solve this equation. This R is equal to D by lambda. Add directly external surface and air gaps. find out the u value by 1 divided by sigma r. So here you are having a problem for fabric heat loss calculation. So here you are having a detached house, measures 8.5 into 12.5 meter in the plan. The area of the house is 8.5 into 12.5 meter. So the house has a hipped roof. Hipped roof means sloped roof, and the height of the walls is 4 meters. The roof is insulated at ceiling level. So the roof is having an insulation at ceiling level. Ceiling level is something like fan level. Fan height can be called as ceiling level. Glazing accounts for 20% of the total external area. So this house is having the total external area of 20% of glazing area is there. So all the windows are provided for 20% of the total external area. The house has a front and a back external wall, front and back door, which is each door area is 2 meters. That means two doors are having the total of 2 into 2.04 square meters area. The u values of the building elements. So u values are given here. So these are the building elements. These are the building elements and these are the u values. External walls is having 0.25 and windows is having 1.5, doors having, these are the u values here. So this is the calculation for fabric heat loss. Before you go to this calculation, there are calculations of areas provided in the next slide. So imagine that your room is like this, 8.5 multiplied by 12.5 meters. So 8.5 width and 12.5 meter length. So you can find area is equal to length into breadth. So if you calculate this, you will get the area as 106.25 meter square. So the area of the roof for the purpose of calculation is same as the area of the floor. So this is the same area for roof and area for floor. So roof area is 106.25 meter square and floor area is 106.25 meter square. So here roof and floor, you write these areas here. We'll check table next one. I'll complete all the calculation first. So calculation of area of walls. The height of wall is 4 meters. So now we are having 4 walls, 1, 2, 3 and 4. 2 walls of 8.5 meter width. This wall and this wall is of 8.5 meter and this wall is of 12.5 meter. So total you are having 4 number of walls. To calculate the area of wall, for this the formula can be length multiplied by height. So area of walls is, area means length multiplied by height. Length is 8.5 meter and height is 4 meters. So we are having 2 number of walls like this, one wall and second wall. So again coming to 12.5 meter multiplied by 4 meter, one wall and 2 walls. That is the reason it is multiplied by 2 and 2. So totally the area of walls is 168 meter square. So in the question you can see this 20% of the total external area we are having glazing, that means windows. So glazed accounts, windows are for 20% of the total external area. The total area is 106 point, the total external wall area, the external wall area is 168 meter square. In this 20% means 33.6 meter square. Area of doors, we are having 2 doors, external door and internal door. Each door is of 2 meters. So 2 multiplied by 2 meters is 4 meter square. So the area of walls is 4 meter square. Now go back to table. So building elements, you just write these 2 columns, building elements and u values from this question. Just fill this building elements and u values. After that areas, area of external walls. So area of external walls, how you get this area of external walls? This 168 minus 33.6 gives you 133. So this is area of walls and you take 20% from this area of walls, that is external walls is only 130.40. In this windows you are having 33.60 and this doors is 4. So from area of walls remove this 33.6 and 4, then you will get this only area of walls. So simple write external walls excluding windows and doors, separately write doors and windows. Roof and floor is same here, so roof and same. The temperature difference, so you can see this temperature difference. So generally assumption we are having the design internal temperature is 20 degrees centigrade and the external temperature of 0 degrees can be assumed. So we are designing this external temperature is 20 and internal temperature is 20 and external temperature is 0. So delta T means difference between internal and external. So 20 minus 0, it is 20 degrees. So it is equal throughout this calculation. So now heat load calculation, just multiply this column U A delta T. If you multiply these three, you will get this answer. Once you got all these things, the total fabric heat loss calculated by sigma is equal to 2468 volts. You keep it in mind, we will use it later again. So now heat loss calculation. So how can you calculate this heat loss? We are having ventilation heat loss. The formula for ventilation heat loss is QV is equal to CV multiplied by N multiplied by V multiplied by delta T over 3600. It can be defined as watts or joules per second. You can read what is QV, what is C, and what is N, what is V, and what is delta T here. So if you these are the assumptions and these are the rules how to take the specific heat capacity, what is delta T, what is N, and you can directly take it as 0.5. And what is the volume of the building? Volume of the building means area multiplied by height. Volume is area multiplied by height. This is the volume of the building. If you solve this, you will get this ventilation heat loss QV. So total heat loss is fabric heat loss plus ventilation heat loss QF plus QV. So if you calculate all, the total heat loss is 3885 watts. These are the two important problems from this topic. After that, you can just go through this heat loss between theory and practice, how the heat loss is differences between theory and practice. There is a difference between the calculated heat loss and the predicted performance about 20%. This is because of these factors. So resistance to the passage of heat, how this passage of heat can be resisted. So where a building is heated, it is advantageous to use the thermal storage capacity of a dense material on the inside face of the wall with the insulating properties of a lightweight material behind. This is thermal storage in walls. So how the sound transmission, this is also important topic. We are having two types, airborne sound and impact sound. So these are the two causes for this sound transmission. So how sound transmission is happened? The heavier and more dense the material of the wall, the more effective it is in reducing sound. So you just, when you are coming to the class, just go through this sound transmission and these slides. If you have any doubts, resistance to the process of heat, we will discuss this in the class. Come prepared with these two problems. I will be giving you some activities with different numerical values to solve these problems. Hope you come prepared to the class well, and just this is important one, airborne sound and impact sound, how this happens. That's the reason I'm asking you people to read it and understand and come with some questions where you didn't understand anything. We'll have a chance to discuss this in the classroom. So these two are again important slides. Thank you students. See you in the classroom this week.